Okay, I'm going to do 10-2. And I think this is really, really cool because it also has one of these diagrams. And that's going to be a recurring theme. So I'm going to go ahead and get 10 minutes into this one. So similarly, we have a rod. Oh, it's a bar. So it's a square, rectangular. Cross section 1/2 inch by 1 inch. Has many different loads. So these could be also holes drilled in, and this could be a vertical beam that you lay down horizontal just for convenience. So this could be some crazy load, and then there's maybe something hanging here. So it's got something going on. But there's no moments on this, so it's definitely in balance. Okay, anyway. So this could be a real world loading scenario. So we got 5 kips, 4 feet over. So now the distances are important. So with stress down in axis, I sort of just didn't care how long it was. But now you're talking about changing length over original length, so the original length is going to matter. So you need this information now. 7 kips. 6 kips. And 8 kips. Okay. And this is 5 feet. And this is 3 feet. So just preliminary work, I want to run through and find my loading, my axial load here. So I'm going to pretend there's a cut here. And also, is this static? 13, yes. So to keep this structure static, there's a net acceleration of 0. So 5,000 pounds this way, 5,000 pounds that way. So that's compression. So I'm going to go through and make a chart of all this. So maybe right here. So I'm going to say 2 squares is 5,000. I'm going to go 4 over. And now I don't know where the loading is. Okay. So I'm going to cut here, right here, to include this first 7 kips, 5 kips. So now we're talking 2 positive. So this little area is under 2 kips. So is that 5 right here? So just under here, all the way until the next thing. Right there. All right. I'm gonna cut the other way because it's easier for here. So I got 8. 8. And then 6 kips. 8 kips. Okay. So the net at this break is again 2 this way. So that's tension. Tension, 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 compression. So yeah, we're going up, 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 up. Except it's 2 to 2, so it's going to stay 2. Oh, wait, these are the same segment. Okay. That makes sense. So now it goes up to 8. So this was 2 squares away was 5. Let's go a little above that line. Okay. And so finish it up. So now negative 5 kips, 2 kips, 8 kips. Okay, and this is 4, 5, 3. So this is only 3 right here. So this is the end of my graph. Cool. Now with that information, we can determine. Also, is the bar just 1 by? Okay, so 1/2 by 1 inch. So that's going to be 1/2 inch squared. Yeah, so area is just base times height. Okay. So now I start off with Hooke's law. Okay. We're going to be provided the material constant. Yeah, it's 30,000 KSI. I'm going to sub in what I know about these two formula. That sigma is force over area, and that strain is change in length over original length. Okay. So now I've got force over area, constant, change in length, original length. And I've got area is constant, so 0.5 down here. F is going to be different for each one of these. E is constant, 30,000 KSI. This is inch squared. And then, sorry. My change in length is different and my original length is different. So those are all my unknowns. And I really want to know my change in length. I bet determine total axial deformation. Yeah, so I'm gonna have to go through and get delta for each 0.5 inch squared, 30,000 KSI. Okay, so I'm just gonna call this segment 1. My first length was 4 feet. Shoot. I'm going to need that in inches, so I'm going to do 12. That force was negative 5. 1,000 pounds per square. No, this is thousands of pounds. These are in inches. This is in inches. And this is in thousands of pounds per inch. So my units are good. And then D2 was only, no, it's 5 feet. 2 kips. 0.5 inch. 30,000. And then D3 is 3 feet times 12. And it's at 8 positive. Okay. Now, if I were... Nah, I'm just going to multiply them all. So my load here changes to, let's do 2. 5. And this is in inches. 8,000. Length 3. Inches. So now my total, deformation total, -16 plus 8 plus positive 1/100th of an inch. Cool, thanks.